Welcome back to Daily Dose of Space. Today we're diving into a brand new discovery from the James Webb Space Telescope, something astronomers genuinely didn't expect. Because deep inside massive clouds of gas and dust, where newborn stars are still forming, Webb has detected an intense ultraviolet glow that should not be there. It's rewriting how scientists think stars are born, and what it means for the planets that form around them. Let's get into it. The cradle of stars. To understand why this discovery is surprising, we need to step inside the birthplace of stars, giant molecular clouds. These are cold, dark, extremely dense, and completely opaque to visible light. Inside these clouds, gravity slowly crushes clumps of gas until the core becomes hot enough to ignite nuclear fusion. This process takes millions of years, and during most of it, light cannot escape. Especially high-energy light, ultraviolet radiation. In fact, the standard model says newborn stars, called protostars, should be cool on the surface, deeply buried in dust, surrounded by thick disks of gas, and therefore almost UV invisible. So far, so simple, and then Webb looked. Webb sees something impossible. Using its infrared instruments, JWST can peer directly through the dust. But astronomers didn't expect what they saw next. Protostars, some only a few 100,000 years old, were releasing far more ultraviolet radiation than theory predicted. Not just a little more, a lot more. This UV glow appears around the forming star, its accretion disk, and the jets shooting out from its poles. For context, the UV energy levels were closer to what you'd expect from older, more massive, more mature stars, not fragile cosmic infants. So what's causing this? 3 hypotheses are now being debated. Hypothesis number 1, violent accretion. The first explanation involves accretion bursts, sudden episodes where material falls onto the star extremely fast. When gas crashes into the surface of a protostar, it heats, instantly emits shock radiation, and can create short, powerful UV flashes. Think of it as star-forming fireworks. This would mean newborn stars are far more chaotic and violent than the textbooks say. But there's a problem. Some of the UV detected is steady, not burst-like, so astronomers looked deeper. Hypothesis number 2, magnetic chaos. Another idea is that young stars have extreme magnetic fields. The magnetic field lines twist and snap, just like solar flares on our sun, but far, far stronger, releasing ultraviolet radiation. This is supported by the shape of the UV glow and the fact that many protostars have bipolar jets. This mechanism could produce continuous UV emission, but there's a catch. Models predict strong magnetic heating, but not enough to match what Webb is seeing. Which brings us to the strangest possibility. Hypothesis number 3, UV leaking through the birth cloud. Some scientists now suspect the dust cloud itself is not as uniform as we once thought. If the cloud is full of tiny holes, cavities, and low-density channels, UV radiation could escape in ways we didn't anticipate. This would mean star-forming regions are more porous light escapes, earlier chemical reactions inside the cloud change, and planets forming in these regions experience a very different radiation environment than models assumed. This is the hypothesis with the widest implications, because UV radiation plays a massive role in chemistry. Why this matters for planets? Here's the big consequence. UV radiation is one of the main drivers of complex organic chemistry. It can break molecules apart, trigger new bonds, form prebiotic compounds, and transform icy grains inside protoplanetary disks. If newborn stars are blasting far more ultraviolet light than expected, then the first steps toward habitability might start much earlier than we believed. This could change our understanding of how atmospheres form, how water survives, how life-building molecules appear, and how stable early planetary systems really are. In short, Webb is exposing a hidden ultraviolet engine in the earliest stages of star formation. And this is just the beginning. Webb continues to rewrite the rules, from galaxies to black holes to the birth of stars themselves. If you enjoyed this deep dive and want a daily hit of space news and cosmic mysteries, don't forget to subscribe to Daily Dose of Space. And let me know in the comments. Do you think stronger UV radiation makes planets more likely or less likely to become habitable? Thanks for watching. See you tomorrow.